Hi, so today I'll show you how you can try an interview in Shakra. Suppose we go with a backend developer role.
Welcome to your interview. Today covers a theoretical round followed by one coding problem. Take your time and think out loud through each part. Ready? Let's begin. What is connection pooling in databases and why is it important for backend systems?
Connection pooling in databases is actually trying to keep alive the connection between to the database instead of re-establishing them every time on each query.
Good start. Why does reusing connections matter in terms of performance and resource usage on both the application and database side?
Actually, I haven't studied this much, so I don't think so I will be able to answer.
Think about what happens technically when a new database connection is created. Is it a lightweight operation? And can a database handle unlimited concurrent connections?
No, actually, a database cannot handle unlimited concurrent requests. So,
Right. So if the database can't handle unlimited concurrent connections, what problem might happen if every request opens a brand new connection instead of reusing existing ones?
it will increase network latency in the product. Like too much traffic will crash the backend system.
All right. You touched on latency and system overload. That's the key idea. Let's move on. Moving on. Explain the difference between synchronous and asynchronous processing in backend APIs. When would you use a message queue?
Synchronous processing in backend APIs means that after the client has sent a request, it gets stuck till the backend does not fully resolves it. And for the asynchronous processing, the client gets a immediate response from the backend, and the actual work is done in the background. It is resolved in background, and then later on, it is sent asynchronously.
Good start. Can you explain in what kind of real world scenario you would introduce a message queue and what problem it solves compared to just handling everything synchronously?
Suppose a user wants to skip a question, he can also just skip it clicking on next question.
Great job! Moving to the coding section. Here is your problem.
Okay, so for solving this LRU cache question, I think we will be using a stack and an array data structure.
A stack alone won't give you O1 for both updating usage order and accessing by key. Think about two things. How do you get a value by key in constant time? And how do you quickly move an item to most recently used position when it's accessed?
Okay, for keeping the key value paired, I think we should use a map. It will help us in achieving the O of one time. And uh, for moving the elements, we can use a linked list.
Using a map for O1 key lookup makes sense. Now for moving elements. If an item is accessed and needs to become most recently used, can you efficiently remove it from its current position and move it to the front in O1? What kind of structure allows that?
Yes, I said I would use linked list for it.
Yes, a linked list is the right direction. Good. A linked list helps maintain order. Would it be singly or doubly linked and why? Also, how will your map and linked list work together so you can remove a node in O1 when it's accessed?
I think I will go with a single or maybe a doubly linked list. And this is my small implementation till now. Can you just check it and tell me if I'm going in the right direction?
You're definitely on the right track with a doubly linked list plus map. That's the correct direction. A few things to look at. I don't see implementations for remove and add. Without those, this won't compile. There's a syntax issue at the end with extra closing braces. When you update an existing key input, you remove the old node but never delete it. What happens to that memory? Also, think carefully. In your design, is head and X truly the least recently used or the most recently used? Make sure your eviction logic matches your ordering.
So I'll end the interview now, and it will auto submit it if I end it as well. And now I can see a detailed report generated. It just shows us the ranking or the marking criteria for each question so that there is complete transparency. Okay. So here I can see a complete per question breakdown, um, and also for the coding question I can see this.